Good evening, everyone. Uh, Thanks for joining the session on how to guardrail the PI data in PostgreSQL using PG-anonymizer while maintaining the security and compliance across all the environments. I'm Boopathi, Senior Delivery Consultant from AWS ProServe. I have Vishnu with me. He's a Delivery Consultant from AWS ProServe. This session is an attempt to introduce you to PG-anonymizer. If you haven't used it, if you have already used, you will learn some of the new features in the PG-anonymizer. So here is our agenda. We will start with the problem statement. Then we will understand the architecture of PG-anonymizer and how it is evolved over the period of time. Then we will dive deep into the masking strategies and masking functions available in the PG-anonymizer. And then we will end the session with key takeaway and a quick demo on some of the masking strategies. And then we'll open the floor for Q&A. Here is our problem statement. So we have seen like a developer often approaching DBAs to refresh their test database with prod data, right? They need a realistic data for various reasons, because they want to do performance test, or like they want to replicate the prod issues for debugging and bug fixes, or they are trying to solve some rare edge cases, right? What if the prod data contained PI information in it? Because the regulatory compliance like GDPR and HIPAA mandates there should be a strict control over your PI data, and they suggest never to share the PI data with your non-prod databases, because most of the data breach happens in your non-prod database more than in prod databases. So this is a conflict, right? Like, how do you bring your prod data which contains PI data without exposing the PI data to the test environment? That's where we have the PG-anonymizer. So Postgres uses PG-anonymizer extension to mask the data. So what PG-anonymizer does is, like, it hides or replaces your PI data in a way that it remains usable to your authorized user, and it holds no values to the unauthorized user. So this PG-anonymizer was in the existence for in the market for a while now. It was launched in like 2022, the first version, but it didn't gain its popularity in its first version because of the limitation it had with the core engine. Because the core engine itself is developed based on PL/PSQL stored procedure, and it lacks tight integration with. Sorry, give me. It's not showing. So it lacks the tight integration with the Postgres kernel. Because of that, you have to manage everything through schemas and views. And because as you are managing everything through schemas and views, it is easily bypassable the masking data, and you can easily read the underlying raw data from the table. Also, it lacks row-level isolations, and it lacks lots of features, not much additional masking strategies. It is very slow, and it is sequential and prone to memory leak, and it is very vulnerable to security hacks. So understanding the security risk involved in version 1, the PG community has completely rewritten this engine in version 2 using Rust framework. So this Rust framework provides tight integration with your Postgres kernel, and it makes the extension is part of Postgres core engine itself. So because now it's part of Postgres core engine, you can manage, it can able to manage the background processes and shared memories, making it very significant, fast and safe. Also, this Rust frameworks let you to execute the query directly on the table, rather like in the version 1, like where we completely relied on views. It lets you to execute the queries directly on the table and mask the data during the query runtime. And with version 2, it offers you lots of new features, including it supports parallel processing, and it prevents memory leaks, and it provides lots of advanced masking functions, including role level isolations, which is not available currently in version 1. It also offers additional masking strategies, and it is completely secure and safe to use. So here are the masking strategies supported by postgresql-anonymizer. So we have dynamic masking, static masking, backup masking, and replica masking, and masking data wrappers. Let's dive deep into these masking strategies. So let's understand how this dynamic data masking is working in version 1. Then I will compare it with how it is improved in version 2. So as I mentioned, version 1, it was completely built based on the PGConf core engine. It is also called dynamic masking is also called schema based masking, because it's completely relied on schemas and views. Let me explain this process, how it happens. So if you see the picture, the DBA is creating a declarative masking rules. So masking rules is nothing but applying masking function on the column which you want to anonymize the data. So once the masking rule is created, this masking rule will be updated in the default masking policies created by the extension. Once it is updated, you have to create a masked user. We have to label it as masked. So and attach the policy to the masked user. Once the policy is attached, now you just go and execute the command start dynamic masking. So what happens in the background is it will create a new schema called mask, and it will create a masking views. It is a view on top of your underlying base tables in your user schema. So and it also like change the search path of your user itself to mask schema. So now what happens is whenever the user go and execute the query, it will be redirected to the mask schema, and the queries will be executed from the mask schema. Basically, it uses view to execute the query. So and all the masking functions will be applied on top of the view, and it will retrieve the data. But the catch here is like it is easily bypassable. As long as the user has an access to the underlying table or schema, if he has the permission, he can easily change the search path to his user schema, and he can query the table, or he can just prefix the schema name in front of the table name, and he can directly query the table. So it is, very vulnerable to security. So it is really unsafe to use, and it lacks native role isolation support, because it doesn't allow you to create multiple masking policies. Because it creates only one masking policies in version 1. So now if you see version 2, you do the same thing. Like if you see the picture, like again you create the masking rules, masking user, and everything will be the same. But here, instead of starting the dynamic masking, you have to enable the transparent dynamic masking. Once you enable the transparent dynamic masking, now the user will just go and execute the query. If you see here in the diagram, so there are two users. One is normal user and another one is masked user. Both are executing the query on the same table. For masked user, it returns the masked data, and for the normal user, it returns the raw data, raw PII data. How it happens is, like when you execute the query optimizer will get the object ID of the table in your user query, and it will also check who is executing that user query, whether it is a masked user or it's a normal user. If it is a masked user, it will just go to the masked policy, and will check whether for that particular object ID, it has a masking rule created for it. In case if the masking rule is created for that, it will just apply that masking rule while the query is getting executed in the runtime. So all the masking functions will be applied and the data will be anonymized during the runtime. So that's why it is very transparent, and it is called role-based or identity-based transparent dynamic masking. So it supports native role isolations because it allows you to create multiple role masking policies. And it is highly recommended to use in production database wherever you want to implement the role-based isolations. Then we have a static masking. So static masking is nothing but it modify your data in the table directly. Basically destroy the data with replaced values. It is irreversible. It cannot revert back the data because it is the changes are permanent. If you see in version 1, like we used to use data wrappers to do the anonymization. It is very slow. Again, it is prone to error, and it will break the code because everything is we are managing it through wrapper. It has lots of maintenance overhead. So with version 2, like you have to again you have to set all the masking rules, and you have to create a masking user and everything. It is same like dynamic masking, but only the command is different. You have to start the static masking. So what happens here is it literally execute the update statement on your table, and it will replace all your data on the PII column. So this is also called as an in-place update because it's directly updating the table, and it is sequential. And it is, it is a sequential operation too, and it is time consuming because in version 2 it never supported parallel processing. But version 3, which is released just a month back, it supports parallel processing. You can, when you start the static masking, it can the static masking can happen in more than one table at a time. And it is a CPU and resource intensive. You have to be very careful in using this. Not advised to use in production database. Better to disable this feature in the production database. It is recommended to use only in the test database where you want to anonymize the data. Next, we have a backup masking. So this is a something like where you don't want your PI data to leave your source environment without masking the PI data, right? So what happens is like how it works is the same. Again, you have to configure the rules. Then you have to create a masking user, and then you have to attach the policy to the masking user, and you have to enable the transparent dynamic masking, and then you have to as a masked user you have to run your PG dump. So what it does is it will read the data from the source table, and then it applies all the masking rules on the fly in the memory, and then it will write the masked data into the dump file before it lands into the target destination, target database. So it is it anonymizes the data while you export the data, right? So it is significantly faster. It is better than static masking because static masking create lots of bloating problem because of the direct update to the table. But here it is handled through dump, so there is no bloating, and it is faster, and there is no additional logging generated for this. It reduces memory and overhead and the execution time of the masking function too. Only disadvantage is it needs an extra storage to store your dump file. That's very common. It is recommended to use like wherever you want to do data refresh, whenever you want to do data refresh with your prod database, right, in your test environment. So that is the use case for this. Then we have a anonymous replica masking. So this is a real-time masking, like it leverages logical replication of the Postgres. So it works based on the pub-sub model, like primary database act as a publisher and the replica database act as a subscriber where the extension is installed. So whenever there is a change made in the primary database, it gets streamed to the replica database, and the extension sitting on the replica database will intercept the changes, and then it will apply the dynamic masking. It will apply the masking rules on the data that it receives. So it is completely on transit, and it is completely on live data. So this can be used in cases like where you want to maintain hot staging environment, or like wherever if your BI users need real-time dashboards. The only limitation is like it requires an additional server to run your replica database, because when you set a logical replication, you need an additional server to run that. So it keeps the data always fresh. So it is recommended to use wherever like you want to do frequent refresh with your prod data. Next we have masking functions. These are the advanced masking functions introduced in PG-anonymizer in the latest version. So we have an advanced faking. Basically what it does is it will replace the original data, the original names with the fake names. Also it supports the localizations. It supports up to 7 languages. And we have pseudonymization. It is same like advanced faking, but only thing is it is deterministic. What it means is if you have a referential integrity between foreign key relationship, in that case you can use this. It will always create a same name for your parent and child table. And then we have a generic hashing. It is also create a deterministic hashing value, same like pseudonymization. And randomization will create a lots of random values. Then partial scrambling is for your credit card number, like where you want to mask partial credit card number or phone number. And conditional masking in case if you want to apply filter on your masking rules. Then you have a custom masking, like in case if you want to create your own custom masking functions, you can use this to create your own custom masking function. And finally we have a generalization. Basically it replaces the original value with a range which contains your original value. Basically it is not suggested to use in prod. And finally this is here is a key takeaway, like so be wise to choose the masking strategy based on your use cases. So choose static masking in case if it is like if you want to anonymize the data in your test environment, and choose dynamic masking if you want to implement role-based isolation in your prod database, and anonymous dumps in case if you want to use if you want to make sure that your raw PII data never leaves your prod database in unmasked state. Now I will hand over my session to Vishnu. He will go through the demo. Over to you.
Thank you, Boopathi. I hope my sound is clear. Now you may have heard about many masking functions, many masking strategies, and how you can implement. So we'll see some real-world use cases and how it can be implemented. Here I'll be taking you through 2 of the important scenarios. One is backup masking, which is very popular and useful in your own day-to-day projects where you want to get fresh data from prod for testing, or you wanted to take a dump from production to your lower environment for your development use cases. So we'll be going over the backup masking, how it can be implemented, and as well as dynamic masking. So where you'll see how you can create multiple masking policies for different roles, and basically that's how you want it in prod. You may have different roles, and different users should see only whatever data which is intended for them. So we'll see those scenarios here. And first of all, I'll take you through the prerequisite. So here I'm using the latest PG-anonymizer version, which is version 3.0.13, which is released in Feb 2026. So this version has, as Boopathi earlier described, like we have new features which is enhanced on top of version 2. So version 2 can be considered as the first stable best versions, where we have solved most of the previous issues. So as a prerequisite, first of all, for this version 3.0.13, it supports PG14 and above. So first of all, you need to install the correct version of your PostgresQL. Download the PGRX extension, which is the REST compiler and REST framework, which is required to connect your extension to your Postgres. Then set up the anonymizer extension, get the correct version of the extension, and then you're good to go. Now you'll see how we can implement. For that, first of all, I am setting up a database. So I'm creating a sample prod database here. And in order to initialize, first I have to set the property. Here I'm setting it at the database level as alter database, then set preload, session preload libraries as anon. So anon is the default extension name. Either you can set it at a database level or at a server level so that every database will be affected. Then you have to create an extension and initialize it. So during the initialization, all the preloaded libraries, sample dataset, everything will be loaded to the internal table, which will be used by the extension for masking, faking, all those different functions. So you can see here the extension has been set it up using these commands: create extension and anon.init for initialization. And once everything is done, you can just check with your anon.version command to see the anon is initialized with the correct version. Now, for the testing, I am created few sample tables. So we have a customer table with few PII data and an order table. And down below, I have inserted few sample data to this table, which is having few PII data. Now, we'll see the sample data which is loaded here. So in customer table, I have name, email, phone number, SSN, salary, all these and can be considered as a PII data, which should not be exposed to unauthorized persons. Then in order table, we have card number as well. Now is we have to declare the masking rule. So we are using declarative syntax here to create masking rules. So you can see here the syntax goes like this: security label for anon is the extension. So this is the default extension. Then column name, and mask with function anon dot the function name. So I'm using faking, and I'm using partial masking for email, pseudonymization for phone number, noise for salary. So likewise, we have plenty of options. So you can choose based upon your use case, and it should be declared like security label in a declarative syntax. So I'm declaring the rules for the customer table. Same way down below, I have declared it for the order table. So according to your use case, like you can choose whatever is required for your customer. You can choose the function whichever you want. According to this, you can have plenty of options as we have described earlier. Faking or pseudonymization according to the referential integrity or whatever is the use case. So once the declarative syntax is ready and you have declared all the masking rules, now as the first use case, for backup masking, I have to create a DEM. For that, I'm creating a new user with the required permission for taking the backup or DEM. So I'm creating a DEM by anon role with the required permissions. And below, I am enabling the transparent dynamic masking. So for that, I'm setting it right now at the role level. So it's not at the database level. I'm setting it for the particular role. So that whenever this role try to access the database, this engine will intercept and it will rewrite the query and it will mask the data on the fly. So once it is done, you have to set the particular role DEM anon as masked, so that the masking is enabled for this particular role at the database level. Now I'm exporting a DEM or taking a PG DEM by using the PG DEM command below, using the no security labels command. So here no security labels is, we have the security labels created at the production environment, which we don't want in the lower environment. So I'm using no security labels, so none of the security security policies or rules may not be copied. It will only be copied the masked data. And down below we can see after the DEM is created, I'm verifying the DEM. So you can see only masked data is available in the DEM. So the data, none of the PI data has been copied to the DEM. So this DEM is now safe to import to any of your lower environment. For that, I'm creating a sample test DB and restoring this DEM file to the test DB. And for test environment, I am creating a new user which required permission only to access the test environment and no production access. Now we'll see how the user can access. So we have a Postgres, which is the super user. When it tries to access the prod, as usual, it can see the PI data since it is a super user. Now when it tries to see the test DB, it can see the masked data because none of the PI has been copied in test DB. So it's accepted scenario. Now if the test user tries to see the masked data in test DB, you'll also see the masked data because no PI data has been copied. And just to test, if you try to access the prod DB, no access because that's the usual case. Test user should not have permission to access the prod. So this is the usual scenario which you can see in any of your projects or in real world use case where you need to refresh from data from prod to any lower environment. Now we'll see the another scenario, that is dynamic masking using role. So I am creating separate roles based upon the requirement, and will create policies for that. Here I am creating a new role called analyst, who want to access the data, but only it should access the permitted data. No PII should not be visible to the analyst. For that, right now I'm creating a new policy other than the anon, which we have in the previous example. I'm creating a new policy called analyst policy. And after that, you can see that I'm creating a new policy called analyst policy. And for the both customer table and order table, I can create new set of rules for the particular role. Same way you can create n number of roles, and for each role you can create n number of policies. I'm creating a new analyst role here and setting the role as masked. So whenever this analyst try to access the prod data, he can see the data, but it will be masked according to the rules which we have set earlier. So you see, all the previously defined rules are set, and role is set as masked. Now finally, we have to set the transparent dynamic masking as true. Here the difference is from previous example, I'm setting it at the database level. So any user in prod try to any role from in prod try to access the DB, it will be intercepted. So it will be always monitoring all the actions of any roles. So here again, admin can see the PI data, but when analyst try to see the data, he'll only see the masked data in any of the table according to the rules which we have set earlier. So to summarize, we can create a number of policies in a real world use case in production, like for analysts or for BI developers, and we can mask your data or secure your data according to the requirement. So these are the few of the real world scenarios which you might be encountering in your day-to-day work or in your projects, which you can explore and implement and secure your data according to the security norms. So I hope you got a good idea of how this can be implemented and how easy you can implement it. So without any overhead. So it's all declarative syntax which you can declare in your DDL, and you are good to go. So with this, I have come to an end, and we are open for questions.